Hello.
Does it work? Okay. Hello and welcome. Good evening, everyone. Welcome here on 6th, if I count correctly, 6th meetup evening of WeStream. Today we are pretty loaded with pretty interesting talks. And the first of them is Honza from Czech TV, and he'll speak about live encoders.
Live encoders and other options. Okay. Hello, everybody. I'm really excited to be here today. Many thanks to organizers that I can open this evening with my speech. I'm Jan Dvořák from Czech TV. You probably know who we are and what we do. We are a public institution and national broadcaster. But besides that, we do a lot of internet stuff. We do products like e-vysílání ČT24 and many others. We are distributing our products via web, smart TVs, apps, and of course we do a lot of online streaming, and this is the reason why I am here today. We run 9 24/7 channels and up to 12 additional channels. Probably you didn't know that we run 9 channels because we have regional mutations of our first channel. Ad hoc channels is usually used for sports events or for thrilling broadcast from the Chamber of Deputies. Several fun facts. We have our own zip code and firefighter unit. And our archive, video archive, is bigger than Netflix because we have more than 260,000 titles. 17,000 titles from Netflix. It's a global number. For a Czech audience, it's around 8,000. My speech today will be about mostly hardware live encoders and other possible options. Basically, it's dedicated hardware appliances for real-time video compression and streaming, and they are optimized for high efficiency, stability, and low latency. Today, I will speak about broadcast-grade solutions. Of course, we use smaller devices as mobile encoders, as a field units, and other different encoders, but I won't cover them today. You can imagine this device can process up to 16 streams in one time. Of course, you can't expect 16 streams in 4K, but for your imagination, how great looks like. Main vendors for these solutions, Harmonic, AVS, ATMS, Cinemedia. In the brackets, you have the names of their products for these appliances. These devices are quite capable devices which support multiple input and output formats directly out of the box. So on input, SDI, transport stream, HLS, and many others. Output, usually transport stream, HLS, smooth streaming, and the others. From that point of view, we call it encoder, but it's encoder, transcoder, and packager in one device. SRT protocol, I have it also in brackets because SRT is quite modern protocol, but it's not widely adopted, so usually you can't expect SRT support. Audio and video codecs, MPEG Layer 1, AAC family, Dolby family for audio. It's widely supported, but for Dolby, you can expect some extra expenses for licenses because the Dolby family is licensed extra. In the video, MPEG 2, MPEG 4, HEVC is quite common. If you are looking for HV1, you would be looking in vain, probably, because it's still not supported in those devices. For us, it's really important, closed caption and subtitles processing. Those devices usually can work almost with every possible standard, even on input, even or output. You can do tricks like extracting subtitles, burning them in the picture. So many possibilities with work with subtitles. From other features, you can work with eSAM. You can imagine some markers in the stream, which can be utilized for inserting ads or breaks or jingles and other kind of content. These devices usually are capable to do some DRM work, but in my opinion, it's not quite right place to do the DRM and video encryption, but they are usually capable to do that. And also very nice feature, quality-based variable bitrate is usually supported. QVBR, this term was introduced by Amazon. With different vendors, you can get different names for this function, but with this quality-based variable bitrate, you can save up to 50% of the bandwidth, so it's a really nice feature. Of course, in some cases, it's licensed extra. This slide is about some magic during the processing input. You can do a lot of different things, but those are quite common in every device supported almost every vendor. It's some resizing, the interlacing, noise reduction in video, in audio, loudness control, watermarking, downmixing, and other stuff. It's quite handy because all those functions you can get out of the box. And especially loudness control can be very handy. What's really important for those devices, they are designed for high stability. So it supports some redundant deployments. So basically, you can deploy those encoders in a farm or cluster with central management. So you can get very stable solution with automatic failovers. You can check inputs and map some automatic behavior after signal loss or some case when you can monitor some artifacts. You can switch automatically to different device within a second. Those devices usually can run with active setup or active backup setup, especially when you run those devices in active setup. The switch from one to second device is super fast. From the networking perspective, SNMP protocol is usually supported. You can get some email alerts. And of course, those devices offer very comprehensive APIs, so you can almost the whole device can be controlled via APIs, so you can integrate the control into your administrations. Okay, I was talking about capabilities of these devices, but how these devices look like, because I don't know if somebody see the encoder in your past, so drum roll, please. Yeah, it's a server. Basically, this is HPE ProLiant server because the manufacturers usually use common hardware, common servers as a hardware base. But some vendors, another drum roll, please. Offer some orange metal shiny covers on it. So it's probably the same server. It's AWS Elemental, and I'm not sure if they are running on Dell or HPE, but Harmonic and Cinemedia for sure, they are using ProLiant servers. So when you Google the picture of Cinemedia encoder, is the same, but in the middle there is a Cinemedia logo. It's ProLiant 360 server, Gen 11, I think. So. Let me introduce our setup. As I mentioned, we have nine 24/7 channels and up to 12 occasional channels. For this, we have 2 devices in full redundant setup for 24/7 channels and 2 more devices for occasional channels. With this setup, we still have some option to the future expansion. We also have deployed management server for administration, and we did some integration via APIs with our administration for some features like logo management and the others. Okay, and what are the alternatives for hardware encoders? To introduce this topic, it was 1 year ago. We were forced to decide if we continue with hardware encoders or we cover this need for live stream encoding with different solutions. So I did my homework and I checked almost every possibility and did the use cases, and those are some alternatives. Of course, you can use cloud services. The whole big 3 offers their packages for encoding. It's media, live media services, and media and entertainment. So you can get those services from the big players. There are a lot of specialized companies like Max, Brightcove, Bitmovin, Axionom, Vovza. And I'm sure that I have forgotten for many others because there are dozens of companies do that, and everybody is best. And of course, the classic vendors for hardware encoders, they are trying to catch up the cloud wave. So they are offering cloud solutions. Harmonic call it VOS, Automated on Live, Cinemedia. Of course, you can think about the hybrid deployment to the private cloud. Also, Harmonic Cinemedia offers that. Vovza, Bitmovin offers these solutions. And last, not least, my beloved open source project, ffmpeg and GStreamer, also could be option for you. And of course, many hybrid scenarios. Let's say you can build the base with hardware encoders and use cloud solution for spikes. For example, Harmonix API is the same for cloud services and for physical devices. So with that setup, you can do one job and utilize cloud and hardware appliances. Some pros and cons of these approaches: hardware appliances, reliability. We are running our previous solution for several years without outage. So those devices are quite reliable, and usually when you are buying the new device, you can buy support for 8 years. It's quite a long time period, so they are really reliable and optimized for 24/7 run for months without outage. And you can get a lot of functions out of the box. The con, it's quite obvious, the high price on the beginning, because there are quite expensive devices, and as I mentioned, you need to count with extra costs for licensing. Let's say Dolby's licensed extra. And of course, this solution is less flexible because you have some fixed capacity. Cloud services, flexible, scalable, low initial investment, but in long term, the cost can be really high, especially when your volume of stream is rising up. And of course, there is limited customization. Usually, we have only limited functions via API, and those services are not so they are not evolving so quickly. Open source, very low cost solution from the beginning, zero costs for software, but it requires technical expertise, and there are some maintenance challenges. Also, tuning this solution is quite hard. And of course, you can hit some performance issues because the utilization of hardware is not ideal. When you are thinking about your encoding solution, here are some tips what to consider. In my opinion, the most important thing, type of content, or other words, the scale. It's really different when you are thinking about 24/7 broadcasting of several channels, or if you are thinking about one-time period or one-time event or period event, because the demands for stability it's really different. For one-time events, you require flexibility. And the costs in the cloud for temporary needs could be reasonable. Also, open source solutions can be deployed on demand to minimize costs, but you need some infrastructure where to deploy them. So the first thing is the type of content or the scale. Of course, if we are talking about one-time event like streaming national championship, it's a different story. Time to deployment, the time frame what you have for your project. Cloud-based solution, it can be deployed really fast and requires minimal setup. Hardware encoders, basically, it's plug-and-play device, but you need to buy them. It can be also tough part because the whole procurement process can take several months. and also you need some time for integration. Open source solutions, yeah, it's quite flexible, but it requires some infrastructure setup and some expertise. Another thing what to consider, your existing infrastructure and your expertise. If you already have some existing hardware encoders or your production chain is existing, upgrading this solution with new hardware could be very cost effective. If you have in-house development team and existing infrastructure, yeah, open source solutions could be very nice way for you. If you have none of these, you probably need fully managed solutions. So go for the cloud. Another thing what to consider is scalability and future growth, because cloud solutions scale very easily, but with easy scaling of the volume amount, the costs also scale really quickly. On the other side, hardware encoders have fixed capacity, so when you are in a relatively stable environment and you can predict the streaming volumes ahead, it could be a solution for you. If you have troubles with predicting your future, it's not a good idea. Open source solutions, yeah, it allows gradual scaling, but on the other side, you need to be very careful about infrastructure and capacity planning. It's quite obvious, the cost perspective. Hardware encoders, they have very low long-term costs because you buy them once, the maintenance costs are usually very low, but it needs high upfront investment, cloud-based encoding, low cost at the beginning, but it can be very pricey during a longer time period. And open source solutions, minimal software costs, but requires infrastructure investments, servers, maintenance, and also personal costs are usually need to be counted in. Quick comparison of costs perspective. And some takeaways on the end. Always conduct a business case analysis for your scenario. Do your homework because it's really important. The scale matters. TCO, always do TCO analysis because in long term the results can be really different, and try to consider some hybrid solutions because this can be most effective way for you. Okay. And the last thing from me, a quick quiz. I hope that you will be successful. As I mentioned during my speech, one thing which needs to be considered when you are thinking about your solution, it's your existing infrastructure. And for us, it was almost the key thing, our existing production chain. And our production chain relies on SDI, which is standard for signal And you know what's this? What's the name of this? I think you are out. I think you guys are out from this. Anybody else? Or if you want to join in, I need the full name of this connector, not an abbreviation.
You won.
I did a quick test before this speech, and I found at least 3 people who knows it.
So is it barrel?
Bayonet?
Bayonet?
No, it's not bayonet connector. So it's tough because I have golden bludišťák for that. So anybody else knows the name of this connector? Guys told that. Okay, probably Špity has.
No, I'm not gonna enter into that. So we mentioned barrel or bayonet.
Bayonet.
Pick which one do you want. So bayonet something.
But it's quite a. It's familiarly called Dvořák. So it's Dvořák and it's Bernal Neil Conselman, the name of 2 engineers who invented this connector.
So yeah, I was completely off because it's bayonet network connector.
It's Bayonet Neil Conselman, but I would be okay with SDI connector. Okay, so probably.
Throw it into the audience. Oh.
So golden bludišťák for you. Okay, thank you very much. Time for your QA.
I will start. Maybe I will repeat that question like during the evening because more of you is speaking about live. What about a comparison of low latency and ultra low latency in between the solutions?
Of course, those devices are capable to produce low latency streams, and it's quite usual. The regular latency you can get about 4 seconds on encoder. It depends on the whole chain because it's different when you distribute the stream right from the encoder or you ingest the stream to another platform. When you do the DRM encoding, so it's up to whole chain, but those devices are usually low latency, very low latency devices.
Hi, I would like to ask you, so you said that last year you had a big decision to make to go either hardware or cloud. I guess you choose the hardware, stay with the hardware. Then my question would be, how is the sustainability, or how do you feel about the sustainability and energy saving with these encoders? Because you mentioned the...
Yeah, we had a long experience with hardware encoders, and basically we are really satisfied with this solution. So this was one important thing. We are running them and we are satisfied with this solution. And the other thing is existing infrastructure, because basically Czech TV is broadcaster, so we have the whole infrastructure of video engineering rely on SDI. So it was our first choice because you basically need to connect those connectors to some device. So existing infrastructure, it's the key. And also the costs, because as I mentioned, 9 24/7 live channels. When you do the math in a cloud, it's quite expensive to for 24/7 live streaming. So it's about costs and existing infrastructure in our case.
Any other?
And of course, I'm covering the broadcast scale. So for small projects, one-time projects, it can be really different.
So maybe you covered my next question in that you mentioned hybrid approach. So do you use a hybrid approach? Do you have a hybrid approach to your linear encoders, hardware ones?
No.
No?
No. Because I've designed the solution to cover some part of our streaming, and now we still some spare capacity, because those devices usually have some input cards, so we can buy more cards and more licenses to those devices. So I was trying to design this solution for the whole life cycle, let's say for 8 years. So I hope that we can stay with 4 devices, and we can grow with those devices in the future without adding new devices.
I'm new to this encoders, but I have a question since you compared with hardware and cloud. Does it really matter where this hardware is sitting? Is it like, if you want to have a globally distributed solution, do we need to deploy hardwares in multiple locations? Is there a benefit if we move to cloud?
Prosím. Okay. Okay, to the audience, sorry. In your case, some hybrid solution probably would be better, because Czech Television has everything in one location. In Czech Republic, we have Czech audience, and we distribute our signal locally with local CDNs. So for us, it's on-prem scenario, but for distributing the signal over the globe, I would go definitely for some maybe private cloud solutions, but in that case you need to count really carefully. But buying physical devices for global distribution nowadays, I think it's not a good idea.
So I have 2 more questions, actually. So in the beginning you said that you have bigger archive than Netflix. How is it with the storage? If I know that it's a little bit different than the encoders, but if we are talking about hardware, are you storing it over the cloud, or is it still like in data center somewhere with the...
It's in a physical data center, and we have partner for data storage. It's the same partner who solve the CDN distribution for us. It's O2 Czech Republic. So our archive is held by O2, and now it's around 2 petabytes.
Okay, yeah. Well, and the second question was actually about the subtitles and captures. You said that, so I'm from Czech Republic, I'm Czech, so I know that probably Czech Television has mostly Czech audience, but you said also that the captions are very important for you and like for the Czech Television. So if you have implemented already this feature in the hardware encoders, or if you...
It will be in the near future with new encoders. Older encoders were capable to do that, but we didn't implementing. And it's not even about subtitles, but also with audio. In the future, when we are switching to the new solution, we will be capable to deliver multi-audio and multi-subtitles in different languages. And it's not even subtitles, it's also closed captions. There is some difference. But it's topic for after the speech, difference between closed captions and subtitles.
Really?
So I have two. I will pick the more complex one. I'm not sure if you've shown it on the slides at the beginning or not, but where in your production chain did you place these encoders? Are they streaming everything for every partner, for DVB-T, for the satellite streaming, for OTT, or is it just serving some of?
It's just serving the internet.
The internet.
Just
Okay.
internet.
Okay.
The rest, we have classical headends, and they are distributed mostly via satellite distribution. But some companies, they have their own encoders in-house for some special reasons like basketball league and
So
the others.
in this case, you are using them even for encoding to different resolutions, bit rates, whatever is necessary for the internet.
Yeah.
For XTLN.
It's just for internet purposes.
Okay. The next question, hopefully is the last one for me, is was a latency factor for you to choose the on-prem solution? Because the clouds were probably not close to Prague. Closest could be AWS Frankfurt or something like that. Was latency a factor?
Yeah, it could be, but in our case, the latency wasn't the deal breaker because the deal breaker was the existing infrastructure. So I've considered it, but it's not so important. And also with cloud solutions, you can get really low latencies. But it's mostly not about the encoding, the delay, because in production, we have now, let's say, 10, 12, maybe 20 seconds. Maybe Tomáš knows it better in delay. 14. We have 14 seconds delay, and the encoder is just a small part of it. It's also about your buffering strategy in a player. So.
14 seconds in encoder. Yeah, but it's a decision because we decided for the quality VBR, and this takes some time. If we would really aim for low latency, then we would choose different setup, and then of course it's possible to achieve that.
So unless there is another Radek's question, we are like 6 minutes late, so let's have 3 minutes break, and then Ilya will continue.
Thank you.
Thank you very much. So, we are delayed a bit, but let's continue. The next one will be given by Ilya from Radio Free Europe, Radio Liberty. I'm not sure which one is better, but yeah, good luck.
Thank you very much for a nice introduction. So, shall we, right? All right. So, first of all, it's very nice to be here. Kudos to the organizers of the event. It's really great that there is such an event in Prague. So, guys, that's great. So let me first introduce myself. So my name is Ilya Osichev. I have been in the media industry for quite some time, since 2005, and have a CTO level experience in different areas: live production, post-production, broadcasting infrastructure, media, large-scale media infrastructure, and of course streaming. So I was responsible for over 100 end-to-end live events ranging from sports to culture for different purposes: local, nationwide, international. So I think I know something that I'm ready to share with you. I would love that someone shared it with me. So in recent years, I'm focusing on streaming technologies. At RFE, I'm leading Pangea streaming platform. So the platform we develop in-house, and this platform is being used for different large media organizations such as Voice of America, Radio Free Europe, Office of Cuba Broadcast. You might not ever heard of it. So currently we support over 100 news websites, including TV channels in 15 different languages across the globe. So, and today I would like to explore with you some of the challenges you might have working in this large media organization. So, and yeah, so I put some of the pictures to entertain you and show that media technology is at the same time is quite niche technology. And at the same time, a very broad area. So a lot of people working within one media organization may not even know what your colleagues are doing in the next department. Like in every IT company, but compared to IT, it's a much more smaller industry. So, and it actually doesn't matter if it's like a large-scale event, or it's a small event, or it's a 24/7 channel. Nobody really wants downtime. I believe this is very obvious for everyone in this room. So, and I'm not going to focus on this one. So, and let's explore some of the challenges that arise in the complex media environment you have with a centralized distribution like we have as many other organizations. So, let's start with the best effort. So, in most cases, with your laptop or with a camera. Here is an example of the camera with Wi-Fi, built-in Wi-Fi. So you can stream to YouTube or even to CDN. We have some random ISP in most cases that will work. So, and this is called best effort. So you expect everything works. So, and things become a little bit more complicated when you have you must guarantee a certain level of resilience for high quality, high budget, multicam live video production, where many people work on the project. People from Czech Television probably know about this. Yeah, it can be like tens of people, 50 people, hundreds of people. So, and you need to provide resilience and often to many endpoints. So the most extreme, of course, redundancies you may see in some sports events, Formula 1 race, NFL. Not just because there are high stakes, but also because nobody else can afford them. So, and just a disclaimer, there is no one solution, there is no one architecture that fits every solution. So almost every large media organization I know, it has its own unique workflows. It has a lot of legacy, especially if you're a company with 75 years of history and still have radio in your name. So And of course, with the cloud today, we have so many nice and cool options how we can change our workflows. But I'm not going to talk today about the cloud only solutions. I will focus on some real examples. So what is end-to-end? So sometimes we refer in media as a glass-to-glass, meaning like a glass of your lens to your TV. Usually we use glass-to-glass when we talk about low latency. But today I'm going to explore this glass-to-glass when we talk about all the chains, all the parts of the process. So here's a typical chain you have for your live video content. You have, of course, production, you have a contribution. Contribution means you deliver the highest possible quality between your internal departments or like locations. So encoding, packaging, end user distribution, CDN. So, and by no surprise, if you have a degradation of quality or like audio loss, anything at any of the steps, so user will always complain on your last step. And this is why it's really important. It doesn't make any sense where the issue is happening. So here's a nice diagram from one of the vendors focusing on monitoring. So this is how you usually think of the streaming. On the bottom there is example for IP, but let's look on the top of the diagram. So we have packaging, origin, caching, players, some last mile to the users. But on the left we usually see some encoders and some source. So today I'm going to dig deeper into the left part of the picture about the source, how you get to that point, and then we'll continue from them. So because if you have an unreliable source, so then it doesn't make sense to speak about everything else. So this is another diagram from even a bigger vendor. I like it a little bit more. It shows you what happened before. Again, I'm not going to explore all of the possible options how you can make live video. There are so many different ways. But here you can see that there is live production and there is something in between, the transcoding and packaging and CDN. So and there is quite a lot of things going on. This is not even a full picture. So as I said, it's really hard to find two media organizations with the same processes, same workflows. So I see a lot of understanding from the Czech TV. So yeah, so let's talk a little bit about the live sources, just a simplification, what you may have in that case. So when you deal with many different live sources from all over the world, from different places, usually you have some kind of MCR or equivalent. So MCR stands for Master Control Room. Sometimes you can call it Network Control Center or TOC, like Technical Operation Control. So it doesn't really matter how you call it. So in our case, it's a place where you it's kind of a demarcation point between streaming and production. So it's a place where actually you got your sources, you got them monitored, and you always have a reliable connection between the MCR and streaming in that example. So in terms of resilience, in IP world, that will be something like SMT 2022-7, so where you have a redundancy, or in baseband world, as was mentioned, the SDA standard, yeah, so it can be several fiber optics, can be several physical coaxial cables. So you have always a rock solid setup, and the advantage of this setup is that you don't need to deal every time set up your encoder, so you just receive the feed and then it's becoming a matter of configuration. So and this is really a good way to do it. So we have in-house production that is very obvious. It works the same way. So you connect your studios with the same redundancy. So it's your internal infrastructure. It's fully under your control. But things become a little bit more interesting and complicated when it comes to external sources from outside production or some remote studios, affiliates. So let's explore it a little bit when it comes to outside production, because this is how the most major events happening. So in live video production first, we have two major approaches today. I should say that with the evolution of technology, when we shift in our consumption to online media. So live video production still remains highly complex. So you need a lot of talented and people and highly skilled people to have this work done on a high level. So the first approach we have is production at venue. When you have a truck, so this is a truck I was working in 2022. We built it in Germany. That was a nice, fun experience during the COVID time. So this truck can carry up to 20 plus 4K cameras. So you put them on the venue, and whole team works on the venue, and then you need to deliver your programs to your MCR. So, and this is an approach that's used for tier 1 level events. Second approach we have currently is remote production. When you have a minimum equipment on the venue, it will be like camera and like on the picture some transmission boxes, and you deliver all the feeds to your facility, media facility, where you have people in the studio switching the cameras. So both approaches have their advantages and disadvantages, but as I said, when it comes to tier 1 level events, so you still need to have OB-WAN, this car called OB-WAN, which stands for Outside Broadcast WAN. So yeah, so this is a very weird name. Yeah, okay. So let's take a closer look at the OB-WAN. So when you plan your strategy for mission-critical live production and streaming, of course, it's very important to make sure that you avoid any single point of failure. So, and that you need to make sure that all your cameras, all your live sources, graphics, playouts, replays, everything, they are not connected to a single point of failure. So, the production team have all the capabilities to provide you, to feed your distribution, contribution devices with the live source all the time at any circumstances. So, and you actually can be really, really surprised how complex audio could be at live video production. So, my point here is that, no offense guys, but not every live video production setup with fancy cameras and nice looking video switcher are actually capable of providing a reliable mission critical live source. So you must specify this requirement for such a production. So you are not sure, you're 100% sure that your devices are not compromised by a single point of failure. That happened to me like several times when you see a nice setup, and by the end of the day, it's all end up on some SDI splitter. So let's dive a little bit deeper on the, a well-designed OB-WAN. I should not use that word here. So a well-designed outside broadcast mobile unit can create an extremely reliable live source. So the one what we worked with a German company called Broadcast Solution. It can create a extremely reliable live source with a significant amount of redundancy. I would say unless it's literally on fire, it can be operational. So it can hold like loads of half of the power, mixer, video switcher failure, and still remain operational. So that's why it's very crucial to choose the right production setup. So as I said, in some cases you may be offered for your expensive contribution devices to take the program output from just a video switcher or some distribution device. In mission critical, we won't do that. So your program A, program B, or sometimes program C will come from a different piece of hardware, which is protected with 100% real-time redundancy. So I will give you an example how it works with Video Director. So let's take a look at the console. So your cameras are not all connected to the video switcher directly. They're going through a video router. Video router is by default high available designed device. So in case of video mixer failure, Video Director has a small tiny panel on the bottom of the table, and he can continue broadcast even if there is a total outage on the video switcher. So, and while he continues his broadcast, so broadcast engineering team can work on the recovery. So that happened. That happens. It doesn't mean it happened all the time. Yeah, it's just a possibility. Yeah, depending on the age of the truck, of the equipment, of the devices, everything. So that's why it's not only about the right device, but also about the ergonomics in live production. So as I said earlier, you don't stream from live video. You don't stream from this track, even if it looks that nice. That was built in parallel. At the same factory. This is the largest Germany. I'm not sure if it is largest. Germany is one of the largest. It can carry up to 30 cameras. So you may not even have access to such a device. So if it's not your production. So you first need to deliver your source to the MCR because one of the strategy you may have could be an editorial control. You got your source, then it goes to studio, then back to MCR, and then back to streaming. So let's go to the contribution. Yeah, so contribution, how we get the sources from the outside production studios to the MCR. So there are companies that provide you it as a service. I won't name them. There are some of them, big ones. So, but the point here is that you'll never rely on one technology. So I'm not talking about using several devices. I'm talking about different mediums. So it's always a different mix of technologies. So you avoid any medium that you don't have a full control over. So how does this work in practice? So this is another picture. I found this nice car next to the palace. So this summer. So let's dive deeper into the contribution. So the gold standard here, of course, is going send it over a managed network, managed fiber network. So with these networks, this means you have, first of all, you have SLA, and you have a highest possible quality, lowest latency. So when we're talking about the quality, you can use some devices with SPEC 2000, SPEC XS encoding. I'm not sure if you've ever heard of this, but there exists. It's iframe codecs with extremely low latency that can give you a compression within a frames. So, and they can give you bandwidth of around 300 megabits that will be a lossless quality. If you're lucky enough, you can have an uncompressed over a dark fiber, but you need to meet some requirements for distance, for equipment, your ladders. So this is the best way how you can deliver your feed. And if you're talking about the latency, this can be like really, really low. So that's why it's the first place usually used. But sometimes you are not lucky one, and you don't have this option. So in some locations, the only option you can have would be the satellite, which is your second option. And the satellite, in some regions, easily can be the only option. You will go with 2 satellites. So satellite is a really nice technology. I really like it. But there are so many dependencies. It's very complicated. There is one dependency, probably you all know, weather. So, but despite weather, you can still achieve a very high availability here. You can build like 99–98% availability over the year with such a technology. But of course, that's an expensive one. And when it comes to satellite, you always deal with 2 factors. It's bitrate and latency. Yeah, because you cannot send like a 300 megabits or 1.5 gigabit uncompressed SDI video for 1080 50i. So usually it's something around 10 to 15 megabits per second, 20 if you really have a budget. So then for HD 1080. So that's why it's becoming extremely expensive for 4K streaming. Despite that, it's a great way to deliver your feed. It's point to multi-point by default. And it's covered by SLAs, except for the weather. So, and yeah, it's a good choice. So, Last but not least, in my rating today for mission critical contribution, usually as a backup, if you have any of this one, usually as a backup, you go over the public internet with something like SRT or some bonding technology like LiveView, TVU, and this kind of stuff. So people from High Vision who don't know, like inventors of the SRT protocol, they told me a joke that SRT actually stands for Satellite Replacement Technology, which I'm not sure, like really. Well, with satellite, you have SLAs, you have partners, you know your dependencies, yeah. So with SRT, it's really great technology. Like, don't get me wrong. So we use it a lot. So but internet is always best of all, and it's by default. So period. So that's usually you can combine any two of them, and you're good. If you have budget, combine all of them. So usually fiber networks, they on the first method, you usually go through two different passes. So in the first method, usually you have redundancy by default, but we always cover it with any of these others. So okay, let's move on. So once you receive an MCR, that's, as I said, becoming your internal source. But basically, you don't need to do anything. And let's dive a little bit deeper again. So we keep in mind that these sources, these mediums, they may have different latency. So you need somehow to normalize. Yeah. So me personally, I prefer an approach when MCR decides it's on its own which source used as a master for all the downstream connections. So let's say you are good with a fiber, you have a highest quality, and then they feed all your devices, primary backups, with the same content from the same source. If something goes wrong, I don't know, you have some situation and fiber doesn't work anymore, so they switch to satellite. And in that case, it will be a clean switch. You won't even notice anything. Your users won't notice anything, no buffering, anything. So of course there can be some jump back in time on the delay we have. Yeah, but you will continue feeding your devices as like nothing happened. So this is why it's very important, and this is also give you another advantage. You have a frame accurate content on all your encoders. So, of course, there is a place for automation. You can use some changeover devices, so it can be automated, yes. But when it comes to some partial degradation, you may have red and green, black and white picture. That won't be total loss. And for changeover, it won't be always easy to identify the issue, so you want a human control here. So then, once we have handover with MCR and we got a feed on all of our encoders, we have all the streaming related platform routines. You're all familiar, I guess, with, yeah, you need to encode ABRs, and you need to package, deliver to CDN or multi-CDN if you have budget. So then this is one of the approaches. So you can decide how you go there. So then you can decide to, okay, I need one endpoint. I need one HLS endpoint. I need one dash endpoint to feed my front-end clients, my player, basically. So in this approach, you can go with some high available service in the cloud. So you send all this feed. This is why it's very important to have them frame accurate, perfectly synchronized. And this media package service, in that case it's Amazon, it will decide which one is currently active, and you have a single super extremely reliable URL. So in AWS there are playbooks, so you can do a lot of many things. This is probably the simplest one, the easiest one. You can build extremely complex solutions. That's not all. So as in the next example, I'll give you with a global CDN like Akamai, you can build another solution where it's a little bit simpler, and in that case you won't need a perfectly synchronized sources. You may not follow my advice, and you may end up having different sources on your primary and backup encoders. All of these devices can be geographically distributed. It could be different locations, different data centers. So, and that can be tricky to make them synchronized. So in that case, you can follow this approach. You go through pass A and pass B. So you ingest from your APR encoder from one source to a region, then it goes to CDN, and it's become, in that case, as an example, just HLS-A, could be dash. So this dash works the same. And pass B go to the backup region, can be yours, a region of your choice, or could be an Akamai region. And then you end up having two different URLs. So there is one approach, the easy way and the hard way. The easy way, you go with a solution Akamai called HLS merge playlist. Basically, this is an HLS with variants. So you provide multiple variants. Or you feed some backend API, or not backend, or API. So you have to decide yourself which one when you want to use, based on some metrics. So with merge playlist, there is just a disadvantage. It's a nice way to go, but it will work only if you consider failover only on 400 errors. So let's say your stream A is not available and the CDN returns 400 error, then it will fail over to B. And it can be tricky for a front-end player. I know that this setup doesn't work well for all of us. We managed to make it work. So it's up to you how you want to build this other ways. I just want to mention that it's really nice not to have it hard-coded. So because you want to have an option to intervene at any time. Because as I said, in most cases, you won't have a total loss, total damage. Like you may have a partial degradation. You may have like some audio issues on one encoder. So we had a case when there was, okay, probably I should not name the event. So we had an issue with metadata on one of the encoders, and it decided to switch to another color space. So, and one of the encoders was feeding CDN with oversaturated image. So in that case, of course, you can restart, but that will create some outage. Better way, like you just fail over to or completely eliminate the source and continue streaming from the backup. So you can do it like almost instantly. So yeah, a few words about the CDN connectivity, I should have said. So there are ways how you can build your reliable connection bypassing public internet. Probably you know them. Major cloud providers and CDNs, they allow you for a dedicated connectivity. That can be AWS Direct, can be Akamai Direct. So because you want to bypass public internet as much as possible. So here is an example with another approach, which is would be to connect to the network exchange point. So you can, if you're on-prem, can be your advantage. You can extend your network to the network exchange point, and as you see, your CDN can become your next hop from your local network. So here this is a playback public ingest URL, but still it works the same for the ingest to CDN. I will go to the another mission critical endpoint. That will be a social media distribution. Often we do this with in parallel with streaming to CDN, and sometimes it's becoming even more important than the streaming on our platform. So you can use the same approach. This is why this network exchange connectivity is a better way to build that, because you can have connection to many endpoints just with one within the one network. So Google allows you to build a dedicated connectivity to Google Cloud that will cover YouTube, and I know that they are planning to introduce this to the cloud environments, like so they will allow you to build it from Amazon to Google, from probably Azure. It's not there yet, but with on-prem you can do that. So we had a case not that long time ago when two major Prague ISPs were unable to deliver a live stream to YouTube endpoints. So to their defense, we were able to connect. So, but the bandwidth was so low you wouldn't consider for audio streaming. So that's why it's important to have options. By default, when you stream to YouTube or like any other social media, the main approach to have option. This one, I believe, is the greatest option you may have. I wouldn't mention how many times we got 500 API errors. So yeah, don't go that way in mission critical with APIs. I think that's a wrap. So I hope this has been helpful in understanding what kind of challenges, aspects you may have end to end. It's very hard to put everything in this short presentation, but this is knowledge you can typically gain when you work in some media, on TV, and I think this is important to share this knowledge. You cannot learn it anywhere, and I believe this can be available for every streaming enthusiast. I'm ready for your tough questions.
So Radku.
I don't have a question. Thank you.
Best question.
So I was always curious about OB-WANs, and I wonder how often do they actually break? Because there's all this redundancy, but in practice, do they get on fire often or not?
Yes, they do.
They do.
Again, this depends. I will give you an example. Actually, in my previous organization, we've been using OB-WAN built in Czech Republic. Very nice one, very good one that was built in 2002 or 3, I guess. So it's still operational. It's a very good one. But of course, usually, as people, when we're getting older, we're not getting better. So it's very uncommon that it goes totally on fire. But you have it in the most inappropriate moment, like president speaking, or like you're in the middle of a football game. So I had a case when actually we had an issue. This was a major football game, and fiber network just cut, and that's it. So, and we were lucky to fail over immediately, and the reason was within the OB-WAN because of some of the outputs. So when the track travels, it can not always go by good roads. Sometimes it can go through bad roads, and the devices can shake, and connections inside some systems can also. It's a very rare case. It may happen. So that's why you want this redundancy, because you never know. You need not only redundancy. You need ergonomics. You fix it. Yeah. It not necessarily can be a truck. You can put it in the racks. It's also a very common approach. So it depends. But yes, that happens. Yeah.
Like regarding the latency, you mentioned the connectivity via DEC cables and that like everything super fast. So I assume that from the OB-WAN you are still like under 1 second.
If it's fiber.
If it's
Yes. If it's fiber. If it's fiber and it's that not far away, we're talking about frames. So it depends. Yeah. So there is light of speed, so you can measure it, but it's very low latency. If you compress it in something like JPEG XS, so then you will have kind of some latency, but we're talking about like really small latency. I'm not ready to give you maybe an exact number. That really depends on the device and the manufacturer and the brand. So, but this seconds. Yeah. So it's not a huge number.
It's still cool.
It is. Yeah.
So how much latency does a typical satellite link add? Is it like 10 seconds, 15
Satellite.
seconds? Satellite. The satellite feed from the OB-WAN to the control room. If the weather allows, yes.
in sunny days. Even in cloudy days, it doesn't matter. So when it's cloudy days, you need a lot of energy to hit the clouds. The gold standard would be a couple of seconds. So you may remember the time when we didn't have a good cellular networks and journalists from the field were talking to the studio with some kind of delay. Yeah, that will give you an idea. So 2-3 seconds, could be a second. It really depends on the satellite location and it's not that big. It's not 10 seconds.
What's your experience with 5G networks for contribution?
As a backup, perfect. Perfect. Again, in most cases, it depends on your content, right? So you may consider use it as a primary, but from my experience with crowdy events, this is a limitation of probably a cellular technology itself, like GSM technology. When you have a lot of people in one place, 10,000, 20,000, 30,000, so then the network is so unresponsible for your bandwidth. So you can't prioritize the traffic. So if you have a lot of people in one place, you may end up in the bandwidth like 500 kilobits per second or even lower. Or you can lose the GSM network at all. So we had a case that was a large concert when it went completely down. So it depends on the provider, how good they are, how well they are prepared for such an event. Currently, in lots of sports stadiums, you have built-in repeaters and so on. So, but yeah, from my experience, I wouldn't rely it in the first place, especially when it's a crowdy event. But latency is not big as well.
Just to add to this, we don't have any true 5G networks in the Czech Republic in the area yet. So everything's LTE plus some 5G bands at capacity. So you might get an extra capacity today, but you don't get the true benefits of 5G, which is you can get much more users on the same site or antenna, let's say, than you've got with 4G. So like with 4G, you get like 10,000 is a limit or so. With 5G, you can get 2 orders of magnitude higher. So in theory, 5G should help with the bandwidth and saturation problems by like the amount of people being on the same place at one place. Thank you.
Yeah, that's true. But you always keep in mind that this is the best effort. So this is just by default. Yeah. So if you're okay with this one for some event, that may work. Yeah.
Okay. Unless Radek has any other question. We've got like 6 minutes for next talk, so like have 6 minutes break and then we will continue. Thank you very much.
Thank you very much.
Thank you very much.
Yeah.
So now we've got the third, last but not least, talk of tonight, and we will hear from Jakub the news about the incredible text files that are the most interesting of all the text files about the playlists.
So, first of all, I would like to inform you that there are another toilets right over there, so you don't have to wait for the queue. For everyone waiting the queue, there are another toilet. So now, anyway, before we start some serious talks about like some interesting text files, I would like to introduce myself. My name is Jakub Dušek. I'm a software engineer and also a media engineer. For more than 5 years, I've been doing stuff like encoding, using DRM to stop pirates. Here, I was told Mira to explain what a DRM is, but we all know that. It stands for Digital Rights Management, so pirates cannot steal our media and stuff. Just to make Mira happy. I've been also doing some sort of packaging lately, and I've been basically building playlists since 2019. And yes, and since that time, basically since the same year, I've been growing tomatoes everywhere, like in this lovely cabinet from IKEA. We all love tomatoes, right? Who doesn't like tomato? Raise your hand. Okay, no more beer for you. At least to the end of the talk. So, that was too much about me a little bit. Now move to the objective of this talk, to the playlist. So let's talk playlist, shall we? But first, we should talk. Why do we even need playlist? So let's talk some technicals first. The most common techniques of streaming are the progressive download and the ABR streaming. I like to call the progressive download the old way of streaming because it's a very simple technology that's easy to set up, but it's inherently flawed with drawbacks that often lead to buffering issues. It mostly comes from a poor network conditions. The ABR, or adaptive bitrate streaming, tries to address and solve these buffering issues by adapting and changing the quality according to these network conditions by switching the quality. The ABR, instead of handling a large file in the case of progressive download, the ABR instead handles many small segments instead of one large file. And these small segments are then stitched and played on the device seamlessly. That means that some of the heavy lifting needs to be implemented on the player side, on the client side. It's for the basic why we need a playlist, to tell player where to get these small segments. We can think about a playlist as a sort of a as a recipe for the player, and every recipe basically needs ingredients like 3 qualities of video, for example, 2 qualities of audio, and also some side dish and garnishing. It comes in subtitles, and of course it's DRM, because I like DRM. So, with this in mind, let's build our own playlist. Not like something existing, but something new. Let's create 3 files with the list of. With list of these segments, the 1 to 3. Each quality will have its own file, so the player can distinguish what playlist to use and what playlist to use for the switching of these qualities. Well, this is nice and it's simple. We already have like, everything that we need right now for some basic ABR switching. We let the player figure out the rest by hard-coding some values, like, for example, the name of these playlists into the application. And we are good to go, right? Well, unless we are not. For example, a player decides to seek, but we don't know how to seek because we can't. So let's fix that. We can fix this with metadata. We introduced a new field, the segment. This new metadata field will tell us length of all these segments. So segment 1 is going to be 10 seconds, segment 2 is going to be 10 seconds, segment 3 is going to be 10 seconds. This is nice. Now we can finally seek. In the player, we can display time. But we are lying. We are lying to the user because rarely the last segment, for example, will be exactly 10 seconds. So let's fix that. Let's fix that. Okay, nice. So let's fix that, as I said, with more metadata. Let's add this field to basically every segment that we have in the playlist. We can still seek. We can still display time. Yeah, nothing new. But we are finally not lying to users anymore. And we even gained a new ability, because now each segment can have its own length. So we can use that, for example, to insert advertising in exactly the second we want. However, there is still an issue that the application needs to ask 3 times for each of the playlists. Even though that you might have a media that doesn't have the 4K quality, for example, we will still ask for it because it's hard-coded in the application. In this case, the server will return 404, and we can handle it in application as, okay, this quality doesn't exist. But we still have to ask and make free requests. So we can fix that as well. Yes. We can fix that by creating a main playlist. In this main playlist, we list all the qualities that we have. We only have to make 1 request to the server because we have everything in here. We've added more metadata for the player, so the player can figure out the quality from this new quality field that we introduced without any hard-coded value. And we can all agree that this is nice. I like this. Mirek likes it. Do you like it, Mira? I love it. She likes it. Yes. So let's call it a standard and use it everywhere. Because, well, now here comes the issue. The standards are constantly evolving because the technology is evolving, and we have to evolve too. The big correct company have contacted us with to add a new support for their new flashy codec. This is a brand new codec that will help with user experience or on poor network connections. Something that we can like agree that it's nice for a user, right? All we have to do is basically add a new metadata, add a new field to our standard. Let's call it a big codec param, for example. And this parameter can have values either in 1 to 10 or A to F. Here it's C, but you can imagine it's A to F. So we will let then everything handle on the client, because in the end this is just a text file, and what we can do as a text file, nothing. So let's let the client handle this new parameter. Speaking of client, we've built our own player, and soon we figure out that building player is hard. So let's make it easy for ourselves. We follow the initial standard. in the player to add the support for our playlist, and we decided to add the support for the big correct param. As mentioned before, this can be either values 1 to 10 or A to F. Since we know the playlist will come from a trusted supplier, we've decided to implement the number variant only and call it a day. When working with existing standards, even though it's currently our own standard, we are the user. In case of the playlist, either physical or just the standard itself, the player is the user, the player that we just built, for example. And these standards are inherently, or just, from a poor management flawed with edged cases. I highlighted 2 values in the playlist before, being the big correct param one and the segment length for in the quality playlist. As an example, the players usually display time in format that's hours, minutes, and seconds. We all know that. But in this case, how would you display that half of the second? Exactly. But how you wouldn't display that half second? You can, for example, round it, but then you are off by half a second, like through the entire file and through the entire media or the movie. And that might sound like a good idea, but it's not, because these will accumulate over time in the playback, and in the end you might be off by several minutes, for example. The more common case is, however, the big correct param, one in this case, highlighted, because we've decided to make it easy for us and implement only the number formats in our player. The player doesn't know what to do when it encounters a playlist with the letters. For example, when we introduce a new supplier that starts providing us with the big correct param in letters format, which is still according to our standard, but our player doesn't support that. And then what to do? Well, you lose basically support for the codec and for the parameter itself. We should start acting like a business owner, and when we are making decisions, we should be a little bit more flexible and make something out of it when we are building the software. So, for real now, we are dealing with issues like this every day, right? You always have something that someone forget, or there's some discrepancies or inherent issues from previous generations. And when it comes to a playlist, we have to deal with something that's like a decades old now. The 2 most popular playlist formats are the mpeg- and HTTP live streaming. You may know them as files with .mpd extension, respectively .m3u8. Both are standardized under respective standards, constantly evolving and adapting to the industry. These playlists are often created by a packager. That's a software that takes care of the splitting of the media files into the segments and then making the combinations of the video, audio, and subtitles. And we are often on the user side, as I was talking before. We are on the user side of this, and the playlists are supplied by a third party. And here comes the issue mentioned in the previous slide. Because for every dog, there's a different master, and for every playlist, there's a different packager. So what we can do about that? Like, we want to fix that, right? So what should be the solution? What is the solution then? Just build everything yourself. You know, that's a great solution with the best of intentions. Nothing could possibly go wrong. However, that's a lot of work and time, and we often, instead of ideal solutions, looking to find an optimal solution for that particular moment. One of the solutions is the utilization of validators for our case. These validators will validate the playlist that we received against their respective standards and make sure that before it's fed into the player, it's valid and it will work with the player. Then you are left with basically two ways how to fix that or address the issue. You can either contact the supplier and wait until it fixes, but that takes some time, or you can just fix it by ourselves, right? For that, we are provided with tools. For HLS, Apple has provided us with Apple HLS tools. That's a toolkit free of charge. You only need an Apple developer account. You can use it. It contains the media stream validator that you can use to check the playlist. It will tell you all the errors and warnings that are in your playlist, and you can use that to fix the playlist. There are also media file segmenter and variant playlist creator. These two tools at the end should be everything that you need to build your small packager. If you want, go try it out. For the mpeg dash, we have the dash if conformance tool, which is basically just a schema that you can use to build your own tools. And you can use these tools like the media stream validator and the schematron schema to build, let's say, something like a validator as a service, some kind of API that you will feed your playlist to, and it will tell you what's wrong with it. And there are already services, like third-party services, that you will pay for to do this for you. But I highly encourage you to do this by yourselves, because the checks are not universal in these tools, and your business needs might actually vary from the standards. One of the needs that you might need to accommodate your checks is the advertising. We are all familiar with advertising, like with ads in TV or YouTube probably, and at least in the case of a YouTube or something like that, these ads can be like, you can imagine them as a pin in your timeline that will then, will be kidnapped from the regular playback, and you might be returned if you watch the advertising for long enough. These timing marks and can be part of the playlist in a form of SCTF35 markers. That's a standard for making these ads in ABR playlists. And then when player encounters this SCTF35 marker, it asks the ad server for the advertising segment, and it plays the advertising segment. But now, you not only have your player as the user of your playlist, but you introduced a new user, the advertising server, which also needs to understand the SCTF35 markers. So you have to validate your playlist, that it works with the player, and you also have to validate these SCTF35 markers that they will work with the ad server you are asking. And that's not all. Because for the advertising, we have SCTF35 markers, which is like some sort of a universal standard and widely used. But for content protection, you have many DRM systems. And each of them is slightly different than the previous one. And everyone defines its own set of parameters, and everything is different. So now, not only that you are now left with a playlist that you have to validate the playlist itself, that it will work in the player, you have to also validate the advertising of the advertising part. But now you are also validating the internal parts of the digital rights management system that you are using. And that's just another 2 users of your standard of your playlist. And that's it. And there is more. There is like, various pictures format, like HDR, AGL, and the big correct company mentioned before, also known as the Dolby, with their Dolby Vision and Atmos. And you have to validate that your player understands the HDR and AGL marks and the signaling, and also the signaling of the Dolby Vision and Dolby Atmos. That's just another users added to your playlist. And all these details and all these edge cases in each of these is eventually something that will break the player, which leaves a customer with a not working application. And when the application is not working, customers tend to leave negative one-star reviews in app stores. Because let's be honest, how many of you are leaving 5 stars reviews in app stores compared to a 1 star when something's not working? So, what should you take from all of this? Well, I hope I was able to entertain you at least a little bit with a text file that many of us take for granted. We should always treat standards more like guidelines, because in the end, you are not going to the prison for not following a standard, unfortunately. And in here, you have to be the policeman, but you are also the victim of these standards. And for that, you should always check and validate everything. Seriously, validate everything and everywhere. Don't ever trust your inputs. And yeah, thank you for your attention. By the way, we are hiring if you want to join us.
So, who wants to ask about these text files? A lot of questions. Really, no? First row.
So the tooling that you've built, can you open source it?
Well, I never said that we built some tooling. I only presented it as an option. That's some way you can fix this issue, and that there are already existing tools that you can build it yourself and self-host it yourself. Just check the GitHub.
Thank you very much. Nice presentation.
Thank you.
Learned a lot about Manifest. But I have a question about the validation. What actually you do when you find an issue? So how you process it? So do you decline? Okay, we're not going to play this. Goodbye.
Well, you process it basically as any other trauma in your life. But again, as I said, you have 2 options. You can contact the supplier and wait until they fix that. But when it's like a large supplier, they might not want to do that because you're just, this tiny customer and they just can drop you off. And then you can fix it yourself. If you, for example, run one of these tools, nice, it's not working. If you, for example, use one of these tools like the media validator from the HLS tools, it will tell you exactly what's wrong in there. You can put something like the validator as a service or something like a playlist proxy that you will feed the playlist through this proxy and it will fix the playlist on the fly. And then the playlists are stored in a CDN and you do this only once and then you don't care. And it's fixed. You can also fix it on the ingestion side. So for example, when you receive the file from a supplier, you see, I will check it now. You check it, you fix it, and you store it in the fixed format already. But that has a negative downside. You will never ever get back to your original playlist that you've got from the supplier, unless you store a copy of it.
Any other?
I don't have question, I have a comment.
I actually have absolutely no clue what you are talking about.
Thank you.
But it was fun. I've never enjoyed any tech presentation so much as yours. Thank you.
So, do I get it right that I don't have to pack my stuff tomorrow? Good. Thank you.
Does anyone has a question? So, if not even Radek.
So I have one. You've mentioned that some of these standards are decades old. How old are the oldest ones?
That's
Older
a
than
great
my-
question that I do not have answer for yet. If you contact me later, I'm happy to present it to you.
Thank you.
You are welcome.
So thank you, Kubo. I enjoyed it. It was lovely. Thank you everyone for attending. I hope I will see you next time, and I hope you've enjoyed this evening at least as well as I did. So thank you very much, and have a nice evening. Bye.